Hello everyone. So in this video, we will understand what is solid principle with example. So first, let's understand in brief. Then we'll go for the example. So yeah, what is a solid principle? Means like solid principle helps us to write clean, flexible, and easy to manage Java codes. Okay, so let's understand one by one. S stands for single responsibility. Means like one class should have only one responsibility. Okay, and O means like O stands for open closed principle, open for extension but closed for modification. And third is Liskov substitution principle, means subtypes must be substitutable to their base types. Okay, then fourth one is interface segregation principle, means like don't force any class to implement methods that they don't use. Okay, and the last is the dependency inversion principle, means like modules should be depends on abstraction, not concrete implementations. Okay, so now let's go for the example. So here the first is single responsibility principle, means like so one class is equal to one responsibility. Okay, so here see example, one class is their user service. This user service class is having two methods, save user and send email. So this class is having two responsibilities. Okay, saving the user and sending the email. So it is breaking the rule of single responsibility principle. So for that, what we should do, we should create a separate service for email and separate service for user service. You can see below example. See, so here what I have done, I have created one separate class for user service. That user service is responsible only for saving the user, and the separate class for email service, that is like that will be responsible for only sending the emails. Okay, so both class is having its own responsibility, single responsibility. Okay, yeah. So next one is open closed principle, means like class should be open for extension but closed for modification. See here, we have one notification service class with a send method, but inside this method we are trying to send a notification for email and SMS both. Okay, so assume in a future, if we want to change something in that SMS service, then also like it might break that email also. Okay, so what here like this is breaking that open close principle. Okay, so for what we have to do here, we have to like close this for modification. Okay, so we have to open, we have to make it as open for extension but close for modification. So here, if we will like modify something, then it will break that email or SMS like anything. Okay, so to fix this issue, what we should do? So he see here. So here we should create one notification interface like I've created here notification interface with a send method, and a separate class I created for email notification and SMS notification by implementing the notification interface. Okay, so in this after overriding that send method, we can write here logic to send that email notification or to send that SMS notification. So here what we have done, we have closed that interface for extension. Okay, and we have like opened that interface for extension, but we have closed that for modification. Okay, assume in the future if we want to create that service for a WhatsApp message also, so just what we have to do there, we have to create one class with the WhatsApp notification implementing notification interface, and there we can override the send the method, and we can write that message to we can write our logic to send that WhatsApp message. Okay, so next is the Liskov substitution principle, means like sub types must be substitutable to their base type. So here you can see example here in assume in bank we have like multiple accounts are there, like current account, saving account, fixed deposit, RD, but for saving account and current account both are withdrawable. Okay, so it's like base type is withdrawable, but for fixed deposit and that RD the base type is deposit. Okay, because fixed deposit and RD is for like longer period, we are depositing amount for longer period, and in saving and current like we are frequently we are withdrawing the amount. Okay, so see here one class is their account having withdraw method, but in a fixed deposit we are extending that account and we are like overriding the withdraw method. Okay, so like this is not supported in case of fixed deposit. Okay, so this is like breaking the rule for substitution principle. Okay, so see here in green color, what I have done, I have created one interface, withdrawable interface with the withdraw method. Then I have created saving account class by implementing withdrawable interface. And after overriding, we can write here logic to withdraw from saving account. Same thing we can do for the current account also. But here for fixed deposit, like we do not have to implement this withdrawable interface because its base type is deposit. Okay, so here no need to write here, no need to implement the withdrawable interface. Okay, so next is interface segregation principle means don't force any class to implement methods they don't use. Okay, so here I have taken one example for restaurant staffs. So in a restaurant, cook is there, waiter is there, janitor is there. So in a restaurant staff here, if we will create that restaurant staff interface, then in same method only here I have done cook, serve food and clean with three things. And if we assume in want to create that safe by implementing that restaurant staff, then here forcefully we need to implement this serve food and clean methods. Okay, that like this is not really needed for this safe class. So like this is breaking that rule, interface segregation rule. Okay. So here what is we should do? We should create a separate interface for cook, serve, and that cleaner. Okay. And while creating that safe class or waiter class or janitor class, we should implement its own like base class. Like chef is responsible for only to cook the food, so we'll implement the cook interface. Waiter is responsible for serving the food, so we'll implement that serve implement interface. Then a janitor is responsible for the cleaning. Okay, so like we'll implement that cleaner interface. Okay, so this is called that interface segregation principle. Okay, so next is dependency inversion principle means modules should be depends on abstraction, not concrete implementation. Example, here one payment service is there, and this payment service is like this payment service like forcefully like bind to that Paytm payment gateway, like Paytm payment. Like we do not have any option to go for any other payment like Razor Pay and all. Okay, so like forcefully we have to use this only. So this will break the law, break the rule for dependency inversion. So for this, what we should do, we should create one interface, payment gateway interface with the process method. Okay, and for payment gateway, like here, what I have done, I have created a Paytm payment class and the Razor payment class implementing payment gateway interface. Okay, and here in Paytm service class, I'm taking I'm assigning that I'm taking the reference of that interface payment gateway, and here here like it means like dynamically we can change the object of that Paytm payment or Result Pay payment class, and we should use like based on our requirement. Okay, like this is called that dependency inversion. Okay, okay, so like modules like or any class should not depends on that concrete implementation. Okay, always we should go for that abstraction. Okay, thank you.